to the other side of the sun, the light now favours the southern hemisphere, leaving us in the cold and dark, with shorter days and longer nights. In other words, we have seasons.
The life cycle of so many animals and plants is driven by the beat of the seasons. A burst of life in spring, balmy days of summer, migration in autumn, a fight for survival in winter. But the Earth only stays at this 23-degree tilt because of the moon's stabilising effect. As the moon keeps drifting away, the angle of the tilt will change. And over time, the Earth will wobble.
And what will happen then? It's possible we'll go the same way as Mars.
Mars, our planetary neighbour. Today, it spins at an angle of 25 degrees, very similar to Earth. But it used to spin at a very different angle, anything up to 60 degrees. You see, unlike Earth, Mars has no large moon to keep it stable, so it wobbles chaotically. It could almost tip over onto its side.
We may suffer the same fate if our moon moves just that 10% further away. It makes me wonder, what would our world be like? Probably very wet.
If the Earth tipped over and spun on its side, then for 3 months of every year, the poles would be exposed to direct, unrelenting sunshine. Pretty quickly, the ice caps would melt, and a huge amount of fresh water would flood the world's oceans. Sea levels would rise by more than 60 meters. Every coastal city in the world would be gone. And inland areas that survived would be transformed. Las Vegas is dark and very cold. It's -20. Because the sun is pointing directly at Antarctica, for 3 months, Vegas is in the grip of an Arctic winter. But in spring, the sun rises higher and higher in the sky. There's a lull over summer, but in autumn, it gets even hotter. And then the sun drops below the horizon again. And 3 months of freezing winter return. Could we survive? Probably, with enough air conditioning and artificial light. But what of other life forms? Dr. Lynn Rothschild is an astrobiologist working for NASA.
Death Valley is the hottest place in North America. And it turns out that as the moon recedes from the Earth, as it goes away, there are going to be times that the Earth tips over further on its side. And what's going to happen then is that there are going to be parts of the Earth that become excruciatingly hot in the summer, much hotter than Death Valley is today. And in the winter, these same places are going to be bitterly cold, much colder than your freezer. There are organisms that can survive at reasonably low temperatures. Think of penguins and whales and so on. But high temperature is extremely tricky. When you get up at about 70 degrees centigrade, which is hot, but it's nowhere near the boiling temperature of water, chlorophyll breaks down. So all the greenery you see around you would be gone.
So that means no photosynthesis?
Absolutely, so no photosynthesis, and that's what drives life on Earth today, is photosynthesis. Now, as you go up even beyond that, your nucleic acids end up breaking and unraveling, and this is your very genetic material. So clearly, you cannot survive without these.
There are some microbes with a very unusual genetic structure, which can live in volcanic mud pools and geysers at temperatures over 100 degrees. But they can't cope anywhere cooler. And that's the problem. If the Earth tips over, the seasonal shifts will be too fast and too extreme for evolution to keep pace.
Even though there are a few organisms that can adapt to living in excruciatingly hot temperatures, and there are plenty of organisms that can live at very cold temperatures, much colder than your freezer at home, to have the same organism being able to shift between these extremes during the course of a single year is nearly impossible. And I suspect that we're not going to ever evolve one that can do that.
Let us be clear, we are in no immediate danger. It will take at least 1 billion years for the moon to drift far enough away for the Earth to tip over. So we have a little time to prepare. But all this speculation makes me realise how lucky we are the moon is where it is right now. A tiny shift and life on Earth could be so different.
And what about life beyond Earth? Are we alone? Or are there other planets with life forms similar to ours? These radio telescopes are scanning the heavens, looking for any clues.
But where do we look? Even our own galaxy has 100 billion stars. And each one of those stars has who knows how many planets in orbit. I reckon, given what we now know about the moon, how it's influenced life here on Earth, we should focus any future searches on planets with moons like ours.
There are many moons in the solar system, but they're not like ours. The moons of Jupiter are too small and far away to influence their planet. The same is true for the moons of Saturn, Neptune, and Uranus. Only our moon is big enough and close enough to affect us, but not so big to make life here unbearable. It's not too big, and it's not too small.
Like Goldilocks and the porridge, it's just right.
One day, I'm confident we'll find other planets with moons like ours. But will we ever visit them? Will we ever boldly go out into space? If so, then the moon has a big role to play. So far, only 12 people have ever been there, and they brought back a very precious cargo.
That's 20 pounds of rock.
382 kilograms of lunar rock.
Oh, Tony, it's got some beautiful crystals in it. Good stuff.
When geologists analysed these rocks, they learnt a great deal about the composition of the moon and the history of the solar system. But they didn't find what they were looking for: any sign of water. The moon, they declared, was bone dry. But now they're changing their minds. The moon rocks are stored in a clean room at NASA's Johnson Space Center in Houston. Dr. Gary Lofgren has the job of keeping them pristine, as if they were still on the lunar surface.
So this is it? This is a piece of moon rock?
Yes, this is a piece of lava from Apollo 17.
For me, this is a fantastic moment, because I've always dreamed of going to the moon, and so to be this close to a piece of moon rock. This is brilliant.
Yeah, no, this is spectacular. And you look at it, you can see all the shiny crystals reflecting back at you. They're all very fresh. That's just one of the unique things about moon rocks.
I was expecting it to be quite dull, but it looks so shiny.
Yeah, shiny it is. It's because there's no water there to alter or weather the minerals.
So no reactions.
There's no reactions going on, that's right. So that gave us the idea the moon was very dry, very inert. And we thought that for 40 years. But within the last few years, we discovered that there is a lot of water on the moon, in fact. It's water that's trapped because it's cold. It's frozen as ice.
Yes.
Recently, probes have analysed some of the darkest craters on the moon at the lunar poles and have found that they're packed with ice. Frozen water that has come from comets crashing into the moon over time. It now seems there's at least 400 billion litres of water in these craters.
Having water on the moon opens up a whole area of possibilities.
Oh yes, it allows humans to survive. Obviously we need water to drink and water to survive up there. But just as importantly, we can use that water to make rocket fuel, because rocket fuel is gaseous hydrogen and oxygen, and we can make that on the moon.
The Saturn V rockets used by Apollo burned 2,500 tons of rocket fuel to escape Earth's gravity and get into space. But if we could produce fuel from lunar water, that would make all the difference. It would be far more efficient to travel into deep space by launching rockets from the moon, not the Earth. Perhaps one day, the moon will become a springboard for exploring the solar system. Spaceships will make the short hop from Earth and then refuel here before setting off on the long journey ahead. But if this seems a bit too futuristic, then one man has more immediate plans for the moon. For 30 years, space scientist Dr. David Criswell has had a dream to put thousands of solar panels on the moon and harness the energy of the sun.
We can have solar panels on Earth. Why take them to the moon?
You want to take them to the moon because the sunlight on the moon is absolutely predictable. There's no air, there's no water, there's no mechanical vibration, so you don't have to build massive facilities like this. On the moon, you could replace these with solar arrays that are the thickness of tissue paper.
The plan is to build thin solar panels along the rim of the moon so they get almost constant sunlight. The electricity would then be transmitted back to Earth using microwaves.